Good day, this is Professor Will, CBMD PhD. Today's Wednesday, June 8, 2022. It's 3:02 and 10 seconds, p.m. Eastern Standard Time. Today's research on antibiotics. So let's hop to it here. The common drug-resistant superbug develops fast resistance to last resort antibiotic. New research has found that Pseudomonas bacterium develops resistance much faster than usual to a common last resort antibiotic. Date June 7, 2022. Source: University of Oxford. Antibiotics play a key role in human health by helping to combat bacterial infection, but bacteria can evolve resistance to antibiotics patients rely on. Antibiotic-resistant infections now cause 1 million deaths worldwide per year. With a small number of last resort antibiotics available, researchers from the University of Oxford are investigating the process that drives the rise and fall of resistance in common bacterial pathogen populations, which is key to tackling the increase in antimicrobial resistance. The research work has shown that the gene involved in resistance to a last resort antibiotic mutates at an incredibly high rate, allowing bacteria to quickly evolve antibiotic resistance. The research suggests that for this particular case, selective pressures generated by this gene's association with the immune system may have driven the evolution of extra-fast mutation rate that be quickly evolving to make bacteria resistant to antibiotics. The Pseudomonas is a bacterium that commonly causes lung infections in hospital patients. The researchers cultured over 900 populations of Pseudomonas and treated them with colistin. By counting bacteria and sequencing their genome, the researchers could assess how quickly the different populations evolved resistance to the antibiotic and the genetic mutation that causes their resistance. The results show that the Pseudomonas infections quickly evolve resistance to this last resort antibiotic due to a gene that mutates at a rate of 1,000 times higher than the normal background rate of mutations. Mutations in this gene, known as PMRB, allow the bacteria to evolve their resistance to colistin. Researchers suggest the reason for this fast mutation rate could be that the PMRB gene is associated with the human immune system. A rapid mutation rate would help the bacteria to survive by adapting to the fluctuating changes in the immune system. Although the bacteria evolved their resistance to colistin at a much higher rate than expected, the research also revealed a positive outcome. When the antibiotic was withdrawn, the pathogen populations quickly lost resistance as a consequence of the high mutation rate. The researchers now plan to extend their study to investigate what other attributes of Pseudomonas might be involved in enabling such high levels of antimicrobial resistance. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.